What rate of interest compounding annually is required to triple an investment in 10 years? The fact that we're compounding annually means that we'll be using the formula A is equal to P times 1 plus R divided by N raised to the NT. And compounding annually means that we'll have one compounding period in the year, so N will be equal to 1. Now, the main difference with this problem is that the initial principal is not given. But that's not a mistake. Let's think about this to determine whether or not it's actually needed. We're asked to find the rate of interest, so R is going to be our unknown quantity. We're not asked to find the principal. But we know we want to triple the investment in 10 years, so T is going to be 10. And the fact that we're tripling the investment means that while we don't know what the initial principal was, we do know that the end amount would need to be 3 times that initial principal. So let's see if that's enough for us. For the maturity value A, let's plug in 3 times whatever the initial principal was. And again, we don't know what that principal was, so we'll just hold that spot with the variable P, times 1 plus the rate. This is the variable we're trying to solve for, right? We're trying to solve for R here. Divided by N, we know that there was only one compounding period in the year, so N is equal to 1. And then we're going to raise that to the N, which is 1 times T, which is 10 power. So let's just take one quick simplify step to see if that makes the next step easier to determine. And since we're trying to solve for R, that really needs to be the only variable in the equation. And let's notice that we can simplify even more by dividing both sides by that P value so that we end up with an equation that is 3 is equal to 1 plus R raised to the 10th power. Now, before we move forward with solving for R, let's take a moment to mention that no matter what the value of P was, let's say we started with $100, the maturity value would be 3 times that amount if we wanted our investment to triple. And so if we back up here and say that we actually had a value for P, let's say 100, the end amount would be 3 times 100, and our first step would be to divide off that 100, and we'd still end up in this same position. So the point is that it doesn't actually matter what P is. If we were tripling that investment, we'll always simplify down to this equation when we cancel that P out in the first step. And that's why it didn't matter what P was. And it's okay that it wasn't given in the original problem. Now we need to solve this equation for R. And our process depends entirely on what kind of an equation this is. It might be a little tough to recognize, but it's actually a 10th degree polynomial. And we can access this R in order to solve for it by taking the 10th root of both sides to get rid of that power 10. So on the left, we'll end up with the 10th root of 3, and on the right, the 10th root and the power 10 cancel each other out, so we're left with just 1 plus R. Then we subtract 1 from both sides to get that R is equal to negative 1 plus the 10th root of 3. But as we've seen before, we do want to get a decimal approximation from that so that this rate actually has some meaning to us. So we'll say negative 1 plus. In order to say the 10th root in our calculator, we could call this 3 to the 1/10th power, or we could access the 10th root by looking at the math menu and coming down to this function here, which is number 5. And then so when we select that function, it gives me the ability to input whatever index it is that we want. So we could say the 10th root of 3, and the decimal approximation for that is 0.116, which essentially means that we would need an 11.6% interest rate in order to triple an investment of any size in 10 years.